Good morning, good afternoon, good evening, everyone around the world. So today we're going to be looking at breaking down the barriers of reverse engineering. And just to kind of step back for a second, what is traditional reverse engineering? It's really, the opposite of engineering, and that seems, obvious, but, what is engineering? We have a problem, we have a goal. So we start with a list of requirements, we then do some design, we perform some analysis. There's usually some cycling in here, and the goal is to then have a product. Reverse engineering takes that in the opposite direction. You have an existing product. The true, fundamental, purest definition of reverse engineering is to, take something which you have no knowledge of and extract its, design, its architecture, how it's measured, how it's produced. So reverse engineering starts with that product. You analyze it and take that analysis and redesign it. And then, you come up with a list of specifications, documentation, etc. What are we going to look at today? We're going to take a look at doing some individual surface patching, perhaps for making a mating part or an interfacing part. We'll look at automatic surfacing, how we might be able to do this car or this handle or this leg in one step. We may need to align scans to the world origin if we're going to manufacture it. That might be important. We may also want to take a faceted body and clean it up. Not all bodies or scanners will clean up there. But then, if we ultimately need to create that CAD perfect model that has symmetry and planar faces, primitive cones and cylinders, draft, things that we could parameterize and modify. At the end of the day, we're either creating or extracting sketches. We have some great extraction tools where we can clean those curves up. And something that's brand new to R2, we now have a sketch solver, and it's really exciting. I've been with SpaceClaim for over 10 years, and it's really great to now have this. And so we'll see how we can use all of those things to either recreate models or fixtures or design around faceted data. So if you have any questions, please feel free to throw them into the chat panel. Here we are now inside of SpaceClaim, inside of 2020 R2. And I'm going to start off with some skinning of a model. And to do this, we're going to head over to our Tools tab. So inside of the Tools tab, we have a reverse engineering section here. The newest tool is called AutoSkin, and we'll get to that in a minute, but a nice, reliable tool that we've had for a while is called Skin Surface. And right now, this is a scan of a piece of a car, and perhaps we're designing an accessory, a fixture, something that will mate to a certain area on this scan here. Now, you'll notice that there aren't any real simple shapes. This is a very organic body here. So just doing, sketching, the traditional CAD workflow might be a little cumbersome. So with the Skin Surface tool here, what I can do is map out a region. And there's different ways to do this. One quick way is to drag a box with my mouse. And you'll notice that it maps out this grid onto the scan. And you're noticing it's 25 by 25. The initial samples is actually 50. And you can either turn this up or down in order to smooth it out. The less samples we pick out, the smoother it'll be. The more samples, the more detail we'll grab. You can turn this all the way up to 250, believe it or not, but 50 should be more than sufficient for this patch right here. Now, if I go ahead and I hide the scan for a bit, here we can see this. And if I escape out and select this body and just make it opaque from the drop down here, you'll notice that in just a few seconds, we have captured this very organic geometry from this scan, which was faceted with a lot of planar faces to this one large surface here. What can I do with this surface? I could use it for a design. Perhaps I'm going to be creating something that mounts to this part of the scan. It could be one shape, it could be a series of multiple shapes. I could have, let's say, perhaps a pattern, like I pattern this body. Patterning is part of the move tool. I could pattern it around, this circle right here. And then if I want to turn that into solid geometry, I could go ahead and grab it from the tree or from the design window and pull it up and through. Now, to incorporate my two designs together, we have our nice, reliable split body tool. And I can select multiple bodies by dragging a box across them. And then it's asking me to pick a face to use as my cutter. The cut has been made, and I can delete these extra bodies on the bottom. So in just a few pretty automated steps, I now have this custom forming to my scan body, but with just a couple simple faces at the bottom instead of those highly faceted, which if I try to bring into other CAD software or I want to manufacture, this faceted data is just a lot heavier to use, and not a lot of CAD systems or other systems can work with it. So that's the first example. But so if we take a look at how we could use the skin surface tool on this part, I could do patches. I could make a patch like this. And by the way, you can drag these points around in order to change where they are. I could drag and add a point in a red area in order to capture a certain face. So if I want to create this whole model, one option is to kind of do a patch network. Here I can sketch out a patch. Double clicking gives a hard vertice. Single clicking gives a tangency point, and we could have 3 or 4 sides. And if I want to join these two patches together, we have this tool right here inside of skin surface. It's called select geometry, and the geometry is these 2 edges, and it'll join them together, and I can adjust how it does that. And you could imagine I could go around and patch up this whole thing. Now, that may take some time, and I might want to streamline that process. By the way, one nice application of doing this patch, if I'm designing maybe some sort of shin guard or something that is going to be wrapped around the front of this, I could just go ahead and map out that boundary really quickly. It'll create my surface. And SpaceClaim's main creation tool is called Pull. We'll see this used a number of times today, but I could just go ahead and take that surface and pull it out and thicken it and continue my design work from here, using the Pull tool to do things like round edges and add and cut and all sorts of different detail right there. But what I'd like to do is maybe completely skin this model. And so the skin surface tool has another workflow that I can use. And this one involves planes. If I go ahead and I put a plane at the top, and if I hold control while I move things, it makes copies. That's a shortcut we borrowed from Windows and Office. And so if I use that same skin surface tool and I pick this plane, it'll show me where it intersects the scan. And if I pick this second plane, it'll do the same. And it'll essentially wrap between those two planes. It's almost like it extracted an infinite amount of cross sections and blended between them, but all in a pretty automated step. And if that looks pretty impressive, let me take it to the next step, where I'm going to rotate this plane and then move it a little bit closer to the toes over here. So now we'll go ahead and do the skin surface from this plane to this one. And sometimes the preview may not look that great. The tool has a couple different methods under the hood, and the better method, the initial method, doesn't really get previewed. So if you see a weird preview, ignore it. Go ahead and try to click the check mark and see what the result looks like. If it uses the newer method, it'll look good and you won't get an error. You might get an error that says approximate method used, and that indicates the older method. And so here we can see it's fit really nicely, and we'll take a closer look at that in detail in a second. But now we want to do the end cap here, if you will, where the toes are. And using that same select geometry, I could select just the end of this and any point here, and you'll notice it does this really nice dome. And so I can hit the check mark on that, and we'll do the same at the top, and we'll have a nice solid model. So we'll go ahead and click on this edge and a point, and then the check mark. SpaceClaim does the work for me. And if I go ahead and hide the faceted body, now we have this that I could save out to step, IGES, Parasolid. I can bring it into other CAD, CAM, analysis, etc. But, you know, the more detail a model has, the more steps it may take. If there were toes here, I would probably have to do a plane for each toe and then join them together. So that's why we decided to add this auto skin tool. We wanted to eliminate the amount of steps it takes to skin an entire object. So here, I'm going to select the object with auto skin and click the check mark and let SpaceClaim literally do all the work aside from a couple of clicks. You'll notice it goes through some steps, and then the last thing that it's going to say is generating patches. You'll notice it takes just a few seconds here to do 26. The most I've had this generate is 22,000. It took a while. It took about 15 hours, but it was on a topology optimization of a heat exchanger that otherwise would have been impossible to wrap. 26,000 faces. So, or 22, sorry. So here we now have this patch body all done with minimal effort from yours truly. On this last model here, just want to show some really nice extraction and how we can do things like patterns. It's very common here. So if we look at this, we could see this is a little coarse, and we might want to improve our extraction on this. So we could go ahead and use that smooth tool with the volume aware option. And this is going to make some really nice crisp geometry that's going to allow us to insert in some datums a little more easily, also extract some better curves. And if we just wanted to directly 3D print this, we'll have a better model to do that as well. So now you can see much nice crisper geometry. Now for inserting an axis, we have this nice cylinder going around on the outside here, and I can select that and insert an axis right through the center. Now what I want to do is I want to put a plane in through that axis, and I want to take a cross section between these holes, one that also goes through one of these teeth here. So I can turn on the move tool, and we'll just make sure that the move handle is snapped right to that axis just by dragging it. And we'll go ahead, and it looks like right through here, 15. So I'm just going to type in 15.5 to rotate that extra half degree. And it looks like here we're taking a nice clean cross section. So, on that other model, whether I sketched it or extracted, there wasn't a lot of, curves to have to figure out. Here, I'm not sure what this shape is down here, and we've got, all this information and, data in there. Not noticed that little nub was there. Let me just see if we have a good cut on this side. Let me just continue to rotate this around. There we go. I think that looks pretty good. Perfect. So now we can say that we want to extract curves. So previously I showed going into a sketch and while in that sketch extracting curves. But there's a tool that allows you to extract curves through one plane or even many planes. If I needed to take multiple cross sections, either at different areas or I could even take cross sections at different angles, and we will end up doing that. So I'm going to make that copy right like that. And here I'm going to go ahead and use that extract curves tool. And here I'm going to do it one at a time. I don't want my different cross sections to intersect. So I'm going to do these individually, but I have the option to do as many as I want, actually. So we'll go ahead and extract that cross section there. Down this side was the nice clean one. I don't think this is as clean a cut. And you'll notice that when I extract, those curves are selected. And while they are selected, I could either go back into my sketcher and add in constraints to clean it up. So I can go ahead and do that and make it fully parameterized. Or in the interest of the time we have left, I'm just going to go ahead and fill it in, and that's going to make our surface. I can then take the pull tool, and instead of extruding, which the pull tool does really well, I can say that I want to revolve it around our axis, and I've got the main shape of our part. For the other pieces, I could definitely go in and maybe create some cross sections and extract this. But one really useful thing is if I double click on this hole and expand my selection up a bit, I could put a cylinder in there. And I can do the same thing on this little hole right here. And then I could either take our circular pattern tool, or I like doing this with the move tool, actually. I could take these two solids. I can put the move handle on the axis I want to revolve around and just turn on an option called create pattern. When I start revolving, you'll see at some point it'll snap to a certain count. So I could snap it to there. I can see that it didn't snap to the first one, but it snapped, every other. So I just need to double this to 12 and we're good to go. In this case, we'll go ahead and hide the faceted body and our CAD body right here. And I could just go ahead and use our combine tool to do a subtract of these bodies and then get rid of the extra pieces.